Hello everyone, and welcome back to Introduction to Number Theory. This time we will discuss the Euler's function. It is a rather unusual function taken from integer numbers, positive integers, which has amazingly wide applications in number theory and mathematics in whole. So what is the definition of Euler's function? As you can see, Euler's function is the number of positive integers less than or equal to n, which are mutually prime with n. Mutually prime means they have no common divisors greater than 1. Well, let's consider several examples of n and calculate the Euler's function of n, so that we get a bit more acquainted with this new notion. For instance, phi of 1, phi is the Greek letter phi or phi by which we denote the Euler's function. So phi of 1 is equal to 1. Well, since there is only one positive integer, not greater than 1, and it turns out that it is co-prime with 1. Phi of 2 is also equal to 1, because there are only two positive integers, 1 and 2, and 2 and 2, of course, are not mutually prime, so we have only one positive integer that is mutually prime with 2. Correspondingly, phi of 3 is equal to 2, phi of 4 is also equal to 2, but phi of 5 is equal to 4. Why is this so? Well, 5 is a prime number, so all positive integers less than 5 are co-prime with 5. And this will be the case with all prime numbers. So we can say that Euler's function of a prime number is equal to the prime number minus 1, because all positive integers from 1 to prime minus 1 are co-prime with this prime number. Phi of 6 is also equal to 2, and so on. And in order to show you that there are values of Euler's function greater than 10, here we can see that Euler's function of 100 is equal to 40, and it is the number of all positive integers from 1 to 100 that are not divisible neither by 2 nor by 5. And maybe you have noticed that the value of Euler's function is almost always even. Well, indeed, it is a true fact that for all integers greater than or equal to 3, phi of n is even. Why is this so? Well, there is an obvious cause, because for any positive integer which is co-prime with n minus this positive integer is also co-prime with n. So all positive integers co-prime with n form pairs, k and n minus k. Of course, there is a question, what about n divided by 2? Because its pair is itself. Well, obviously n over 2, n divided by 2, is not co-prime with n. So we exclude it, and all co-prime numbers, co-prime with n, form pairs. So indeed, phi of n is even.